Welcome to Smart Contract 30, a huge series that I've done on Solidity smart contract to teach you Solidity and Ethereum by building 30 smart contracts. That's the largest series that you will find on smart contract on YouTube and probably anywhere on the internet. So I really hope that you're going to appreciate it. In this series, we are going to build different smart contracts starting from very simple to progressively more and more difficult. At some point, we will do some smart contract like the DAO, for example, and other very exciting smart contract. So at the end of the series, you will feel very confident and comfortable that you can create your own smart contract. And when I say smart contract, I don't mean super simple smart contract, but I mean really advanced smart contract. So that's really going to bring you a lot. It's going to go through all the different features of the Solidity programming language. It's using Solidity 5.0, so which is at the time of the recording the latest version of Solidity. There are many other tutorials that teach you some older version of Solidity, so you got to be careful. And in this on YouTube, I will give you for free the first 5 episodes. So if you want to continue the series, then you can create a paid account on EatTheBlocks Pro, which is 10 US a month at the time of this recording. It's going to increase in the next few months. But if you don't want to pay this yet, then what you can do is you can create a free account on EatTheBlocks Pro, and you will have the benefit of having access to the source code of the smart contract. So you will be able to follow the video with the video here and the smart contract just below. So it will be really easy to follow. It's free, so don't hesitate to create an account. And if at any time you have any question, then you can ask it in the comments of the video. So if I have enough time, I will answer you. But don't forget that if you become a pro member of EatTheBlocks Pro, then you also have access to a private Telegram chat group where me and other students are connected all the time, and so you get really very quick help. We are going to use an online IDE which is called Remix. So that's an IDE for Solidity. You don't have to install anything on your computer. It's very easy. You just have to go online and you can use it directly. So basically there is almost no setup. You can just like get started like this. Don't worry if you are not already, you don't know much about Ethereum, then we can start this series. It's not meant for people who already have a lot of knowledge. So that's it for the intros. Let's get started. Hey, and welcome for the first day of Smart Contract 30. In this video, I will give you a brief introduction to smart contracts, Solidity, and Remix. We will create our first smart contract and deploy it on the Ethereum blockchain. There are several Ethereum blockchains, and the one we will use is just a local blockchain, not connected to the real blockchain where we have real Ether. So we will not have to spend any real Ether, the currency of Ethereum. Instead, we will use some sort of fake Ether. We will use Remix, an online IDE for Solidity smart contract, so there won't be any setup necessary. So first, let me explain what is a smart contract. So a smart contract is a small program that can run on the Ethereum blockchain. So usually a smart contract is a couple of 100 lines of code. So it's not like huge program that you can find in JavaScript or other programming language. A smart contract, once it's deployed to the Ethereum blockchain, cannot be changed. So which means you can't change its code. You can change the data of a smart contract, but only the code of the smart contract can do that. Once you deploy a smart contract, also you don't need to do any sort of admin. The Ethereum blockchain takes care of running your smart contract. Also, contrary to program that you deploy on a centralized server, with a smart contract, it actually costs money to deploy smart contract, and you pay this with Ether. Finally, with a smart contract, you can do financial transfer as long as the financial assets that you transfer are native to the blockchain. So you can transfer Ether, for example, or ERC20 tokens. There are a couple of languages to write smart contract, but the most popular by far is Solidity. Solidity looks like JavaScript, but the similarity is only very superficial. actually the language is quite different and much more primitive than JavaScript. One of the main differences between Solidity and JavaScript is that with Solidity, you need to compile the program. So with JavaScript, you just write a JavaScript code and you can run it right away in the browser or with Node.js. With Solidity, you can't do this. First, you need to compile Solidity into what we call a bytecode. And this is this bytecode, which is a series of elementary instructions that you can send to the Ethereum blockchain. And that will effectively be your smart contract on the blockchain. Another big difference between Solidity and JavaScript is that Solidity is a type language, which means you need to specify the type of all your variables. And when you compile your smart contract into bytecode, the Solidity compiler will check the type of your variable and will make sure that everything makes sense. So for example, if you declare a variable of a certain type at a certain place and that you try to transform this variable into another type at another place, then maybe that the compiler will complain. In this course, I will progressively introduce you the different features of Solidity as we make progress through the different projects that we will do together. Next, I need to introduce you Remix. So Remix is what you see now on your screen. As a developer, two tasks that you need to do very often while developing smart contract is first, deploying smart contract to the blockchain, and second, interacting with your smart contract, which means calling functions of your smart contract. If you had to do this absolutely manually on your own, you will need to piece together many different tools. And as a total newbie, it can be really overwhelming. And even as a more experienced smart contract developer, it's not something that you would typically do. Instead, you want to use some sort of more high-level tool that help you with the whole development process. Remix does this for us. So Remix is a Solidity IDE. IDE stands for Integrated Development Environment, and you might have already worked with some IDEs such as Eclipse, for example, for Java development, or Visual Studio for C++ development on Windows. So IDE sounds like it's a complex piece of software, but actually in the case of Remix, don't be impressed by this because the Remix IDE is much more simple than other IDEs that I've just mentioned. So one of the main differences between Remix and these other IDEs is that with Remix, it's an online IDE, which means you don't have to install anything. It's available in your browser. You just need to visit this URL. So let's see what are the different parts of this IDE. So on the left side here, you have the file explorer. Well, you can do some file manipulation like creating new file, renaming new file, or deleting file. Here in the main part of your IDE, it's where you're going to actually write the Solidity code of your smart contract. So probably that you're going to spend the most time here. Then on your right here, you have different tabs. So compile, run, etc. So the two most important tabs are compile, where you can configure some options on how you want to configure how you want to compile your smart contract. And second, you have the run tab, where you can deploy and interact with your smart contract. So that's probably where you're going to spend the most time after the code editor here. And you can also have a look to other tabs if you're curious, but we're not going to see most of them at the moment. There is a tab that most people ignore, but actually that is quite interesting, especially for beginner. It's the support tab here at the far right hand side. So if you click on it, you can click on this button, start chatting, and it will connect you with the Gitter chat of the Remix IDE. If you have any question regarding Remix, you can ask your question here and the community will answer you. Please note that this is not a chat strictly about Solidity. So if you have questions about Solidity, you can visit another Gitter channel which is just for Solidity. This one is more like for the features of the Remix IDE. So now let's start to create our simple smart contract. So we're going to create a new file. So we click here, and here we're going to type the name of our file. So we'll call it simple
smart contract with camel case like this, and the extension for Solidity file is .sol, S-O-L, and you click on OK. And we're going to close the other file like this one. So it's basically an example smart contract provided by Remix, but we're not going to use it. Okay, so now we're going to start to write our first smart contract. So the first thing that you need to write in your smart contract is an indication to tell the compiler which version of Solidity is acceptable to compile this smart contract. So you start this by using the keyword pragma, then space, then solidity, and then we're going to use the caret character, and then we're going to type 0.5.1.0. So this means compile this smart contract only if you, the compiler, you are between the version 0.50 to the version 0.5.9 or 999, etc. But not if you are, for example, 0.6.0 or 0.4 point something, because this figure that you see here in the middle, if it changes, it means that there are some breaking changes. So these versions are not entirely compatible. So for example, if you start to write your smart contract when the latest version of the Solidity compiler is 0.5.0, then it's going to be compiled with this version of the compiler. But in 2 weeks, let's say that now your compiler is 0.5.2 and it sees this pragma statement, it will still compile the smart contract, but the compiler version will be slightly different. So you need to be aware of this when you write your pragma statement. Next, we're going to use the contract keyword. So the contract keyword actually defines a smart contract. So you type contract, and then you're going to type the name of your smart contract. So in our case, we're going to call it simple smart contract. And you notice that I used the camel case, which is a standard practice with Solidity smart contract. And then I'm going to open and close curly braces to define my smart contract. Because it's our first smart contract, we're not going to write anything in the body of the smart contract, but in the next videos where all the action will take place is between these two brackets here. So in a single Solidity file, you can actually have several smart contracts. So if we wanted, we could write another smart contract like this, contract simple smart contract 2, etc, etc. But we are not going to do this. We're just going to define a single smart contract. You don't need to do anything to save the file. Remix is on autosave all the time. Now that we have finished to write our smart contract, the next thing to do is to deploy it on the Ethereum blockchain. But before we do this, we need to compile it to a bytecode that the Ethereum blockchain can understand. So let's go to the compile tab and let's see what we have here. So we have a button here, start to compile. So if you click on start to compile here, it will compile the smart contract and you will see here a green box appearing. It's a little bit annoying to have to click on the start to compile button every time you make a change to your smart contract. So instead, we're going to activate the auto compile feature and Remix will recompile our smart contract every time we make a change. It's a much better workflow. Now that our contract is compiled, we can actually deploy it to the blockchain. So let's go to the Run tab and let's see what we have here. So at the top of this tab, we have this section here where we basically configure the parameter of our deployment. So I'm not going to explain in details these parameters in this video because in the next videos of this course, we're going to see them in detail, but just quickly make sure that here for the environment, you have a JavaScript VM selected, and then for the other parameters, you can just leave them to their default value. It should be fine. In the next panel here, you define which smart contract you want to deploy. So as I told you before, in a single file, you can have several smart contracts. And also we have other files with other smart contracts. So Remix needs to know which smart contract you want to deploy. So we just have one here, simple smart contract. So it's already selected. And if we want to deploy it, we click here on the deploy red button. So let's click on it. And just after we do this, we see something appearing here in the deploy contracts panel. So that's our simple smart contract that has been deployed. So we call this thing here a smart contract instance. And we can actually deploy several instances of the same smart contract. So here, if I click on deploy again, then here I have another instance. And let's expand one of these instances. And yeah, so we don't see anything here, but when we will have function in next videos, we will see some buttons that will appear here and that will allow us to interact with our smart contract. One thing to note here is that each smart contract instance has its own address on the blockchain. So here we can see like the address of this instance, and here we can see the address of this other instance. So each of these smart contracts can have data, and if we change the data of this smart contract instance, it's not going to have any impact on the data of this smart contract instance and vice versa. So smart contract instances are independent from each other. That's it for this video. For the next video, we're going to create a Hello World smart contract, which will be slightly more advanced than this one. In this smart contract, we will have a function, and we will be able to call this function from outside the smart contract, and we will learn how to do this with Remix. Hey, and welcome for this new episode of the Smart Contract 30 series. And today we are going to create a Hello World smart contract. So Hello World is a very common kind of tutorial when you're starting something. And in general, you have to echo a string, and that's how a lot of tutorials introduce you to new programming language. And so we're going to do the same thing with a smart contract. The first thing we will do is to create a new file for our smart contract, and we call this Hello World. And remember from the last episode that the extension for a smart contract is sol. Okay. And you might also remember that the first thing we need to do is to specify the version of Solidity that we want to use. And for this, we use the pragma syntax. So pragma space Solidity, then we use the caret character, and then we're going to use the version 0.5.0. Then we define our smart contract with the contract keyword, and this time it's going to be called Hello World with a camel case, so uppercase for H and uppercase for W. And inside here we're going to define the actual code of our smart contract. So if you compare with a programming language like JavaScript, actually you might consider that contract is a little bit like an object in JavaScript. And like for object in JavaScript, we can also have functions. And the way we define functions is with the function keyword. And in this video, we are going to create our first function. So let's do it. Function here. And then we type the name of the function. So far, it's very similar to what we do with JavaScript. And then we open the curly braces, and then we type inside the code of our function. And for our function, we're going to do something extremely simple. We're going to return a static string, hello world. Just like that. And we end every statement in Solidity with a semicolon. So again, very similar to what we have with JavaScript. I have activated auto compilation, and it will make Remix give me all the error and running messages of the Solidity compiler. And as we can see, we have two red cross here. So here, if we hover on the red cross, then we can see the error. And here we have another error, or you can also see it here. And the first error is a syntax error, no visibility, and after it's cut off, but it's basically no visibility specifier specified. So what's a visibility specifier? So in Solidity, functions can be internal to the smart contract, which means, for example, if I have another function here that I will call foo, then this function can be called by the function hello. And so I could say like foo, for example, or I can also call hello or foo from outside the smart contract, and we will see just after how to do that. In the case of hello, actually we want this function to be callable from outside the smart contract, and for this we need to specify the public visibility keyword. Next, we have another error, and basically this error is because we haven't specified what is the return type of this function. So in Solidity, unlike in JavaScript, you need to specify exactly what is the return type of a function. And for this, you use the returns keyword, returns with the S here. So be careful, it's something that tricks a lot of beginners. Here you have to use S, but when you actually return something in the function, the return statement is without an S. So make sure to pay attention if you have to put S or not. And here we need to specify what is the type of the variable, because as I mentioned during the last video, Solidity is a type language, which means you need to specify the type of each variable. So I'm not going to give you a list of all the type in Solidity because it's a little bit boring, but I'm going to introduce new type as we go through the series of Smart Contract 30. So the type of this string hello world is very simply string. So we have string in JavaScript and we also have string in Solidity. Very similar. Next, we have another error of the Solidity compiler. So it basically complained that I haven't specified any data location. So data location is not something that I'm going to teach you in this video. We're going to see this in another video. But basically, very quickly, in Solidity, variables can be saved in different data locations that are more or less temporary. So in JavaScript, you don't have this problem because everything is temporary. When you start your JavaScript process, then all the data live in memory, and when the JavaScript process stops, then everything dies. Well, in Solidity, it's a little bit different because you can save some variable to the blockchain. But very briefly here, actually, we're not looking to save anything in the blockchain. This is just something temporary that we will return from this function. And so we will use the keyword memory, which means this is just a temporary variable. We don't want to save it anywhere. And finally, we got rid of all the errors, but we still have a warning. So if you hover on a warning, then we see it says function state mutability can be restricted to pure. Okay, so this is something important. So in Solidity, function can actually modify something on the blockchain or just return data. So in this case, for the hello world smart contract, I want something extremely simple. I don't want to modify the blockchain at all. So we will use the pure keyword. Basically say this is a read-only function. Don't do any modification on the blockchain and just return this string to me. That's it. We have finished our Hello World smart contract and it's time to deploy it and interact with it. So let's go to the Run tab. And in the Run tab, we are going to deploy our smart contract. So here in the deployment panel, I already have the Hello World compile bytecode that have been selected for me. So I don't need to change this. And here I'm going to click on the deploy button. So deploy, and then I can see my deploy smart contract appearing here. So remember, we call this a contract instance. And if I click deploy here several times, then I have other deploy contracts. We just care about one contract instance, so we can just delete the extra contract instance. And let's expand this contract instance. And this time we see a button appearing. Hello. What a coincidence. It's the same name as our function here. What is this button? So it's very simple. Remix will analyze your contract and will create a button for each function, so you can interact with your smart contract after it's been deployed. In our case, the hello function doesn't take any argument, so we just have a button. But when we will have argument in the next videos, we will see also an input field here. Alright, so let's just click on hello, and what are we expecting? We're expecting very simply to see hello world. So let's see if this works. Yeah, here we can see the return value of the function and we can see the expected string. So that's great. In this video, we have built a smart contract slightly more complex than the last one we created. Well, that wasn't very difficult because the last contract we created was the most simple one you can do with nothing inside. In this smart contract, at least we have a function. So we start to see that how a smart contract can be useful. And we were able to create a simple function that returned a static string, and we were able to call this function from outside the smart contract and read this value. You also learn some Solidity syntax, such as the pure keyword, the public keyword, how to specify the return type, and I briefly touch on the data location of variable, but we will go over this again in future videos. I know that at this stage you probably still have a lot of questions. For example, I haven't talked at all about this panel here, and this is very important, but I don't want to overwhelm you with too much information. So I'm going to distill you all this info in the next video. Don't worry, at the end you will understand everything. Let's continue our journey. Hey, and welcome to the day 3 of Smart Contract 30. In this video, we are going to create a simple storage smart contract that is able to store, modify, and read a string value. I'm going to introduce you the concept of transaction, which allow to call a function and actually modify the data on the blockchain. Contrary to the previous videos where we just read data from the blockchain but it didn't modify anything. So create a new file that we will call simple storage.sol, the extension for Solidity smart contract. And then let's specify the version of Solidity with the pragma statement. So pragma Solidity, and then we use the character and then 0.5.0. Okay, so now let's actually create our smart contract with the contract keyword, contract simple storage, and we open the curly braces and we are ready to actually start to code the smart contract. The first thing we will do inside is to define a variable. So this variable will have the type string. So we just type string. Then this is a variable that will be accessible from outside. So we'll use the public keyword because variable like functions, you can specify their public visibility. And then the name of the variable, so we'll just call this data. And we terminate the statement by a semicolon. We haven't specified the memory location of this variable, but we don't need to because this is a variable declared outside of any function. And when you do this, it automatically gives it the storage memory location, which means that it will be actually saved on the blockchain. So this is not a temporary variable. This is something that you will be able to read in other smart contract execution in the future. When you declare a variable, it's possible to give it an initial value. So let's do it. And we'll just say my data. Okay, and now let's deploy this smart contract. So we'll go to the run tab, and here we're not going to change anything. And so let's delete this. It's like an old contract instance that we don't need anymore. And let's click on the deploy button. Okay, so now it's been deployed. And if we expand our simple storage contract, then we see a button called data. That's curious because if you remember the last episode, I mentioned that Remix will create a button for all the function of our smart contract, but we don't have any function that is called data. However, when we specify that this data has the public visibility, actually Solidity will automatically create a getter function of the same name of the variable, and you can call this function like if it was a function that you created yourself. So let's just click on data to see what happened. And we can see my data, so the static string that we use to instantiate the data variable. It's not very flexible to set an initial value to the data variable and then not be able to change it later in the life of the smart contract. So we want to create a function that we can change the value of the data variable anytime we want. So let's go back to the code editor, and actually I'm going to delete this initial instantiation because we don't really care about this. And so we're going to create a setter function. So we use the function keyword and we're going to call this function set. Then this function set is going to take a parameter. So we need to specify the type of this parameter because it's exactly the same logic as when you declare a variable in Solidity. You always need to specify its type. So string. Then we need to specify the memory location. So that's memory because that's a temporary variable. And then we need to specify the name of this variable. So you might be tempted to just write it like this, data. But if you do this, you're going to shadow the data that is declared here, and you will not be able to access it inside the set function. So we can't reuse this name. Instead, we're going to prefix the data by underscore. That's something very common that you will see in Solidity smart contract. Okay? And then we're going to specify that this function is publicly accessible. So we're going to use the public keyword, and then we open the curly braces, and very simply we are going to assign underscore data to data. So let's see. All right, so as you can see, it's possible to access storage variable defined here inside function. So you just have to reuse their name, and to assign, it's very simple, exactly like in JavaScript. All right, so let's see if this works. So let's go to the run tab, and we're going to redeploy this smart contract. So the general workflow when you're working with a smart contract is you write a smart contract, then every time you make a change, you need to compile it and redeploy it. So if you try to interact with an old instance of the smart contract that was deployed before the last code change, then it will not work. You always have to make sure that you're communicating with the latest version of the smart contract. So here in the deploy contract panel, we can see an old instance of the smart contract, and we can just delete it because we don't need it. So let's delete it, and then let's redeploy the smart contract. So we click on the deploy button, and we have a new instance of the smart contract with the latest code this time. So let's expand it, and we can see the data getter function and also the setter function. So there is a big difference between these two functions. As you can see, the set button is red, and here the data button is blue. So why is this? Is this just Remix that just likes to be fancy and show you different colors? Not really. There is a specific reason for that. It's because the data function just read data from the blockchain, but the setter function modify data from the blockchain and will actually send what we call a transaction, which is something that I will explain just after. So just first, let's do a demonstration of a transaction. So here we have an input field because the setter function accepts an argument, and you can also see the type of the input that you need to provide. So you need to wrap your string by double quote. So here I'm going to start with a double quote, and I'm going to type, for example, some gibberish like smart contract 30 is awesome. Okay, and then I'm going to close the double quote, and I'm going to click on set. Okay, so apparently nothing happened, but actually something did happen. So now if I click on the data button, I should see the updated value for the data variable. So let's click on data, scroll down, and I see smart contract 30 is awesome. Yeah, it works. Let's now explain what is a transaction. So the term transaction does not mean that there is necessarily some money transfer that happen. It can happen, but it doesn't have to. A transaction in Ethereum means that we send a data package that can potentially modify the state of the blockchain. So let's open up the console of Remix to get more information. So here I'm going to increase the size of the Remix console here so we can see a little bit more clearly. And here we have the output of what happened on the blockchain. So we see, for example, that here we had a call. So that's when we clicked on the data button. So we just call a function of the smart contract, but we did not modify anything. So that's not a transaction. And if we scroll up, then we can see that we have another output, which is transact to simple storage pending. That's a transaction. So we can expand here by clicking on the down arrow, and we'll have more information about the transaction. So here first we have a status. Oh yeah, so by the way, this whole thing that you see, it's what we call a transaction receipt. So after you send a transaction to the network, that's something that you will get back. That's a JSON object that's going to describe what happened to the transaction. So here we have the status, and it says that the transaction has been mined, so which means it's been added by the blockchain by an entity that we call a miner. And then we have something which is called the transaction hash. So you can consider that it's like an ID for the transaction. So with this transaction hash, you can go to what we call Block Explorer that we're going to cover in other videos. And with the Block Explorer, basically you can inspect what happened in a transaction. Then we have a from field. So a transaction is sent from an address. So I haven't talked much of what is an address, but basically it identifies data on the blockchain. So anybody can create as many addresses as he or she wants, and then each address will have some data associated to it. So where does this address come from? It comes from here. If we go to this panel here in the Run tab, then we can see, like here we have this label, it's called account. So account and address, they are synonymous. So like, don't be confused if sometime I say account and some other time I say address, is the same thing. So our transaction was sent from this address here that was created for us by Remix. Then we have the to field. So you send a transaction to an address. And in our case, the address that we sent it to was the address of our smart contract. So if you see the beginning of this address 0x5e7, then you can see that it matches with the address of our deploy smart contract here, 0x5e7, etc., etc. Then we have a gas field, a transaction cost, execution cost. So I'm not going to cover what is gas. We're going to see this in a future video, but it's basically some sort of cost that you need to pay to the blockchain for executing your transaction. What is important to remember is that a transaction costs money. It's not free. Whereas when you just do a call, when you just read data from the blockchain, it's totally free. So I hope that now you understand that a transaction and a call are two different things. That's it for this video. In the next video, I'm going to explain you how to specify in Solidity whether a function has to be called as a transaction or just as a call. In the last video, we saw how to create a transaction with Solidity and Remix. However, in the video before the last one, we created a function that was a call, not a transaction. So in Solidity, how can we make the difference between a function that will be executed as a call versus a function that will be executed as a transaction? We're going to see this in this video. By the way, this is the code of the smart contract of the last video, so if you don't have it, you can go to the public GitHub of EatTheBlocks and grab it. So let's create another function that will be a getter for our data variable. So let's create a new function called get, and this function doesn't take any argument. This function will use the keyword view. So View is a little bit similar to Pure that we saw during the first video of this course. So with Pure, you can read a static value that you hardcode in a function. But if you want to actually read the storage of the smart contract, then you need to use the view keyword. So that's what we are going to do. And then we need to specify that this is a public function. And finally, we need to specify the return type of this function. So we use the returns keyword with a S. Remember, it's a little bit different than the return statement inside the body of the function. And then we specify the type of the return variable. So that's a string. And the memory location, it's memory, because that's a temporary variable. Okay, and then we open the curly braces, and very simply, we just return data. Okay, so let's check that everything works well. So we go to the Run tab, and we're going to delete the contract instance that we created before. So let's delete it here, and let's redeploy our smart contract. So click on deploy. Let's expand the contract instance, and let's set the data variable to some dummy value, hello, for example. And don't forget to wrap it between double brackets, between double quotes, because otherwise it will not work. And you click on set. And so let's expand the Remix console to see the output of the blockchain. Okay, so here we can see a message that says transact to simple storage. So here we created a transaction because we modified the data of the blockchain. And now if we execute the getter function, let's click on get. So what do we get? We get hello, and in the Remix console, then we can see that this time it was a call. So function is executed as a transaction and get is executed as a call. And the reason why is because in a get function, we have the view keyword, which indicate that it's a read-only function, but in a set function, we don't have any keyword that indicates that it's a read-only function. So in absence of indication, then Solidity will consider that this function needs to be executed inside a transaction. And before we finish this video, I also wanted to add an explanation in this video about what is this environment dropdown that we have here in the Run tab of Remix. So if you click on this dropdown, you'll get different options, so JavaScript VM, injected Web3 or Web3 provider. And basically this dropdown allow you to choose which blockchain you want to deploy your smart contract to. So when we talk of the Ethereum blockchain, actually there are different networks. There is what we call the mainnet, which is the real Ethereum network with Ether, the currency native to Ethereum. So when you deploy a smart contract on this network, basically you are dealing with real money. So it's the equivalent of production as you would have with web application. However, when you are developing a smart contract, of course, you don't want to deploy to production, you want to deploy to a development environment. And so the equivalent of a development environment for Ethereum blockchain is a local Ethereum blockchain called Ganache. So Ganache is something that is really abstracted by you by Remix, so you don't have to deal with this. But basically, if you want to choose this development environment, you need to tick JavaScript VM. And behind the hood, Remix will run this local Ethereum blockchain, and you will not have anything to do. All the Ether that is in this local Ethereum blockchain is totally virtual, so it's fine if you lose any Ether, you can just reload Remix and new Ether will be created. You also have to know that this local Ethereum blockchain is not connected at all with other computers. It's only local to your computer and you are totally isolated from the outside environment. Also, this local Ethereum blockchain automatically creates 10 different accounts that you can see here. And basically, each of these accounts are pre-funded with 100 fake Ether. So this allows you to to transfer this fake Ether to deploy smart contract without having to mine any Ether. So that's very convenient if you want to develop smart contract. As for the gas limit and the value field, we'll see this in other videos. In the next video, we will continue this smart contract and make it a little bit more sophisticated with arrays. Hey, in this video, we will continue the storage smart contract that we've been developing for the past 2 videos. So far, we've been storing a single string variable in our storage smart contract, but it's not very realistic because in general, we want to store list of data and not just a single string. Fortunately, Solidity has arrays and they are quite similar to what we have in JavaScript. In this video, we're going to change our storage smart contract so that it stores an array instead of just a string. We will also create different functions to manipulate this array. There will be one function to add element to this array, another function to read individual elements from this array, another function to read all the elements of the array, and finally a function to return the length of the array. Let's get started. So let's create a new file. We'll call this advanced storage.sol. And then we need to define our pragma statement, pragma solidity, and then caret 0.5.0 as usual. Then we define our smart contract advanced storage. Okay, next we are going to define our array. So far we've been using string types, but it's not the only variable type that is available to Solidity. We can also represent integers with a uint type. And the way we specify an array of another type is with the square bracket like this. So this means this variable will be an array of integer. Then we specify the visibility of the variable, public, and then we're going to call these IDs. So it's going to be an array that represents IDs. Next, let's define a function to add new element to this array. So we'll use the function keyword and we'll call this function add. And this function is going to take an integer argument. So it's going to be uint. And we'll call this argument ID. Then this function will have a public visibility, and we don't specify the view or pure keyword because we want this function to be executed in a transaction because we will actually modify the storage of the blockchain. Next, we define the body of the function, and here we will reference our array with IDs. And then in order to append a new element at the end of the array, we can use the push method available on the array type. And we terminate the statement by a semicolon. So as you can see, it's exactly the same as in JavaScript. Easy. Next, let's add another function to get a single element from this array. So we will call this function get. And then it will take an argument which is the index of the ID in the array. So this index will also be an ID, and we will call this position. And then we will specify the view keyword because it's a read-only function. Then it's a public function, and we specify the return type. So returns a integer. And then we open the curly braces, and inside the function, very simply, we just return IDs. And to access a specific element of an array in Solidity, you need to use the bracket syntax. And inside the bracket, we specify the position. And we terminate with a semicolon. Next, let's define a function to return the entire array instead of just a specific element. So we'll call this function getAll. It will not take any argument. We'll reuse the view keyword because it's also a read-only function, and then it will have a public visibility. And for its return types, this time it will not be just a single integer, but it will be an array of integer. And we also have to specify the memory location. So you might be wondering why in this function we had to specify the memory location, but in the function just before we didn't need to. It's because for simple type like integer, it's okay not to specify the memory location, but for complex type like array, you have to specify the memory location. Then we open the curly braces and we define the body of our function, and we very simply return the entire arrays just like that. And the last function we will define will tell us what is the size of the array. So we will call this function length, and it will not take any argument. It will be a view function, public, and it will return an integer. And in order to get the length of the IDs array, exactly like in JavaScript, there is a length property for the array type, and then we terminate with a semicolon. Let's now test that everything is working. So I go to the Run tab and I clean up the deploy contract panel because it's like all contract instance that I don't need anymore. And then I make sure that we have the advanced storage contract selected here in the drop down. And then let's click on deploy. Okay, and let's expand this. And first we need to populate our array. So here, for the first position, let's add 10. And in this case, you will notice that I'm not wrapping this with double quotes because this is an integer, not a string. So double quotes are not necessary. So I click on add, okay. And let's add another element, 20. Okay. So now let's try that at the first position, I see 10. So I click on get and I see 10. Yes, correct. Now let's try that at the second position of the array, I get 20. Yes, I get 20. Also, I forgot to mention just before, but as you've just noticed now, the arrays are indexed starting from 0, exactly like in JavaScript. So just a very standard notation here. And then we need to test that the getAll function is working properly. So we are expecting an array of 10 and 20. Let's see what we have. Yes, we have an array of 10 and 20. And finally, how about the length function? It should return 2. Let's click on length, and yes, we have 2. Everything is working in this contract. Before we finish this video, I would like to give you a short explanation on what is gas. Here in this panel, I've already explained what is the environment field and what is the account field, but I haven't explained the two following fields. So I'll start by explaining the gas limit in this video. When you send a transaction to the Ethereum network, you have to pay gas. Gas is an abstract unit that measures the computational difficulty of executing the transaction. If a transaction does a lot of computation, the gas cost will be higher, and if a transaction does less computation, the gas cost will be less. When you send a transaction, you specify what is the maximum amount of gas that you are willing to spend to execute this transaction. By default, Remix puts a very large value here, which is 3 million, but we don't need this high of a value. If you go to the Remix console and you analyze the log of the transaction to add a new element to the array, then you can see what is the actual gas cost of this transaction. So let's scroll up until we find the log for the transaction that we executed to create a new element to at the end of the array, and let's expand this to see the transaction receipt. And we'll scroll down and we're going to see a field which says transaction cost. So it means that we've actually consumed 47,006 gas to execute this transaction. Okay, so let's try to re-add an element at the end of the array, but this time with just the exact number of gas that we need and see if it still works. So here we're going to add, this time we'll add 30. So let's click on add, and then let's scroll down in the console to see if the transaction executed. And yes, like we have a green check here, so everything worked well. Okay, and now we are going to do the same transaction, but this time with not enough gas. So here instead of 6, we'll specify 5, so that's 1 unit of gas less than what we need. And this time, let's try again to add an element at the end of the array. We click on add, and then we get another message in the log here. And this time it's different. We have an error message, error VM error out of gas. So when you see this error message, it means that your transaction didn't have enough gas. And when this happened, the Ethereum virtual machine decide to cancel the transaction and any state change are canceled. However, when this happens, all the gas that you send to the transaction is actually consumed. In other words, it's wasted. So you need to be careful about this gas limit parameter, because if you don't adjust it well, then you will just waste money basically. So then the question is, how do you know what is the proper value for the gas limit? Well, when you're developing, you can set a very high value, and then by analyzing the transaction receipt, you will know exactly how much gas your transaction consumes. And then you just have to set the gas limit to this value. I'm sure you still have a lot of questions about this mysterious gas unit. I will give more details about gas in the rest of this course, but for the moment, we'll just stick to this explanation. In this video, we're going to create a CRUD smart contract. CRUD means create, read, update, and delete. CRUD applications are very common on the web, and in smart contract, we also often need to do these 4 operations. Besides this, I will also introduce you struct, which is a Solidity syntax to represent custom types. So let's create a new file for our smart contract. We'll call this file crud.sol, and then we'll write our pragma statement, pragma solidity, and then the character 0.5.0, and then we use the contract keyword. Then the name of the smart contract is CRUD with an uppercase C. Then we open the curly braces, and finally we can start to code our smart contract. So the first thing we are going to do is to create our struct. So as I mentioned, struct allow to create custom types. So you already have some native type to Solidity like string or integer, but sometimes you also have to have a custom representation of your data. So let's see how it works. So first we use the struct keyword. Then we use the name of the struct. So, and usually we name struct with an uppercase. So we'll do user with an uppercase U, and then we open curly braces. And then inside this struct, we're going to specify the field of this struct. So first we will have an ID, and this ID will be an integer. So uint ID, and then I terminate the statement with a semicolon. And then there will be another field, which will be a string. So we specify string and we call it name. All right, we have our user struct. As a comparison with JavaScript, it's very similar to an object that has no method, but only data. Also, keep in mind that this is just a type declaration. It doesn't actually create any instance of the struct. Next, we will create an array of this user struct. So for this, we can reuse the type definition that we've just created. So here we type user, and then to specify that it's an array of user, we use a square bracket. And then we're going to specify the visibility of this, so it's public. And finally, the name of this array, and it's going to be users with a lowercase u and a semicolon. As we will create new user, we will increment the ID field. We need to keep track of what is the next ID to create the next user. So for this, we create an integer variable that is public, and that is called next ID. Next, let's create a function to create a new user. So we'll define a function called create, and this function is going to take one argument, which will be the name of the new user. So it's going to be a string, and then we specify the memory location and then the name of this argument. And then it's going to be a public function because we can call it from outside the smart contract. And then we open the curly braces. Okay, so in order to create a new instance of a struct, you can use this syntax. So the type of the struct, and then you open parentheses, and then you pass the parameter in the same order as they are defined in the struct type. So first we need the ID, And how do we do for the ID? Because this is not an argument of the create function. Well, just above, we've defined a next ID variable that hold the value for the next user to be created. So at the beginning, it will be initialized to 0. So next ID. And then we use a comma to specify the next value. And the next value will be the name that was sent to the create function. And then we terminate this by a semicolon. All right, but if we do this, it's not going to store the instance anywhere. So we want to put the instance in the users array that we defined just above. So let's do this. So we reference the users array, and then as you remember from the previous video, array have a function called push to append a new element at the end. And in this push function, we're going to pass this user instance that we just created. And is it okay if we just finish the function like this? No, because the next time that we're going to call this function, the next ID will be exactly the same, but it will be a different user. So we will override the same user. It's not good. So we want to increment next ID for the next time we call the create function. So next ID plus plus like this. By the way, there is another way to instantiate a new struct, which is by using this notation with curly bracket. And in this notation, basically you define the key and then the value like this, so name. And if you do this, actually you can specify the key and the value in any order, contrary to if you just use the parentheses and the parameters have to be in the right order. Personally, I like this simple syntax for structs that are not too big, but if your structs start to have too many fields, then you might want to use the other notation that I've just showed you. Next, we're going to create a function to read a specific instance of user. So we call this function read, and as an argument, it's going to take the ID of the user to read. So this is a uint. And we call this ID, and then this is a view function because this is read-only, this is not a transaction. Then this is a public function, and finally in the function signature we need to specify the return type. So first it's going to return the ID of the user, which is return, and second it's going to return the name of the user. And the name is a string, and string is a complex type, so we need to specify the memory location like this. And we open the curly braces. In your previous video, when we returned something from a read-only function, we only return a single value, but in this function we return two values. It's because in Solidity, contrary to JavaScript, a function can return several values. You just have to use a comma to add new value to be returned. So how are we going to find the correct user instance? We're going to loop through the users array, and for each pass we're going to test if the current instance has the correct ID. So first, how can we iterate through the user array? So in Solidity, like in JavaScript, we have the for syntax. So it's exactly like in JavaScript. So first you define the value that will be iterated. So in our case, we define an integer that will be initialized to 0. And then you define the stopping condition. So in our case, when I reaches the length of the array, then we need to stop. So users length. And finally, we need to increment I for each pass. For each pass, we need to test if this is the correct user. So in Solidity, like in JavaScript, we have if statements. So let's make use of this. So if users, and then we access the user instance with the bracket notation, and we pass it the I integer. And then we're going to have a user instance, and to access the field of a struct instance, we use the dot notation. So dot ID. And then we're going to compare this to the ID that we got as a parameter of this function. And for this, we use the double equal. And then if that's the case, then we'll have to return this struct instance. So we use the return keyword, and so we access the struct again, so user I, and the first value that we have to return is the ID, so .id, and second we need to access the name, so .name, and then we terminate the statement by semicolon. All right, let's take a pause here and we'll continue in the next video. So let's continue the CRUD smart contract that we started in the last video. So in this video, we're going to add the update and delete function for the smart contract. So let's first start with update. So here, let's create this function. So update is going to take two parameters. The first parameter of update will be the ID of the user to update. So it's going to be an integer, and then we need to pass the value that we want to update. Here it's going to be string, and then as you remember, for string you need to specify the memory type. So here we type memory. Finally, you type the name of the argument, and then it's a public function. It doesn't return anything, and you open the curly braces, and inside we're going to have a similar logic as in read, where we loop through the user array, and when we find the correct user instance, then we update it. So let's copy paste what we have above, and we're going to change what happened when we find the correct struct instance. So what we're going to do is to access the name field, and we're going to assign it to the name parameter that we received in the function. And that's how you update a struct in Solidity. Oops, I did a mistake here. It's not ID, it's I. And finally, we need to create the delete function. So let's do this. Function delete. And it's going to receive an ID as a parameter. So that's the ID of the user to delete. And here that's a public function. And in Solidity, if you want to delete an entry of an array, you can use the delete keyword. And here, users, and we reference the correct struct with the ID we receive as a parameter. I can see that Solidity is not happy with what I wrote. What's the problem? Oh, I get it. It's because I used the delete special keyword to call my function, but it's not allowed because this is a reserved keyword. So instead, let's call it destroy. Yeah, and now Solidity is happy. Okay, so now we have finished to write the smart contract. So let's make sure that it actually works. So let's go to the Run tab and let's deploy our smart contract. And then we open the contract instance. And then let's create a couple of users. So first we'll have Joe, and then we will have Dan, and then we'll have Jenny. Okay, and now let's try to read these users. So if we go to the read function input here, let's try to read the first user, and we see Joe. Yeah. Okay, let's try to read the second user. We see Dan. Yeah. And now Jenny. Yeah, very good. Okay, so now let's try to update one of our users. So to update one of our users, we need to input the ID and then a comma and then the name that we want to update to. So we want to update Joe, so that's going to be the first user, and then the new name of Joe will be Alice. Okay, so update, and now if I read the slot of Joe, what do I have? I have Alice. Okay, it's working. And now the last function we need to test is destroy. So let's try to destroy Jenny. So Jenny is ID 2. Okay, so destroy. And now if we read Jenny, what happened? Okay, so we see an empty string. So it's been destroyed. So in case you wonder why we still see an empty string and not nothing at all, it's because in the read function, we first try to access the element of an array, but this element does not exist. And then we try to access a field of this non-existing struct. So Solidity will initialize the field of any non-existing struct to the default value of its type. And for string, it's the empty string. Let's take a quick pause here and we'll continue in the next video. Let's continue our CRUD smart contract. In the last video, we finished to implement all the functionality. But if we have a closer look at our smart contract, we will realize that we have some code duplication. So in this video, we will do some refactoring to make our code a little bit better. Here in the read function, we are looping through the user array until we find the correct entry. And in the update function, we do the exact same thing. So this can be extracted to its own function. So below the destroy function, let's create another function, which we will call find. And we will pass an ID to this function. And this function will return the position of the user struct in the user's array. This is a view function that because it does not modify the blockchain. And then we'll need to specify the visibility of the function. So contrary to other functions, this is not a public function because we don't want to be able to call it from outside the smart contract, but this is a function that will just be called from inside the smart contract. And the way we specify this in Solidity is with the internal keyword. And finally, we need to specify the return type. So we are going to return an integer that will be the position of the user struct in the array. Then we open the curly braces and we're going to copy paste the logic to find the correct struct. If we find the correct struct, then we're just going to return the position like this. All right, let's make use of this function. So let's go to read, and here we don't need this anymore. And instead, let's define the position of the user struct in the array, and then we're going to call our find function. So in Solidity, a function can call another, and you just need to specify the name of the function. Very easy. And then we pass the ID that we need to find. And then we can keep the return statement because here and here we reference the correct struct thanks to the I that we got from the find function. And then we access the ID and name field. So all is correct and we can get rid of this. And let's also refactor the update function with the same logic. So let's call find from the update function and let's get rid of the loop. And all we have to do is just to update the correct struct, and to reference it we use the I variable again. And before we wrap up this video, we also need to make a change to destroy. So in the past video, in the destroy function, I simplified everything by basically indexing the user struct directly using the ID value. But the problem is like the ID value is something that belongs to the user struct, and it doesn't need to be equal to the position of the user struct in the user's array. So let's change our destroy function and we'll use the same exact logic as in read and update. So first we find the position of user in the array, and then we delete the correct user like this. All right, so in this video we made our code a little bit better by extracting common functionality into the same function. However, in Solidity there is also another variable to take into consideration. It's gas cost. So sometime when you refactor code like this in Solidity, it can end up with a transaction that will require more gas. So as an exercise, try to compare the gas consumption of the read, update, and destroy function after the refactor and compare it with before the refactor. And in production code, you always want to take the solution that give you the least consumption of gas, not necessarily the one that give you the most streamlined code, which is very counterintuitive when you come from a traditional programming background. Our smart contract is almost finished, but we still have a couple of problems, and we're going to fix this in the next video. In this video, we are going to finish the CRUD smart contract. Our CRUD smart contract has a little problem. If we try to read, update, or destroy a user that does not exist, the smart contract will not complain. However, we should have a feedback that tells us that there is a problem and that this user does not exist. For this, we're going to use a built-in function of Solidity, which is called revert. And since in all our read, update, and destroy function, we make use of the find function, then we're going to go to this function to use this revert keyword. It's going to work like this. First, we'll try to find the user with this ID. And if we find it, the function will return here. But if we don't find it, the execution will continue and we'll be able to call our revert function here. So when we call revert, so in Solidity, when you call the revert function, it's a little bit like when you throw an error in JavaScript. The execution of the program stops and you'll see a message that tells you that something went wrong. Also, if we were in a transaction, any state change to the blockchain is cancelled. And finally, all the gas that would use up to the revert call will be consumed. When you call the revert function, you can pass a string argument to indicate what is the reason for the error. So let's specify that it's because the user does not exist. And when we trigger this function, we should see this error message somewhere. So let's go to the Run tab and we're going to deploy the smart contract and make sure that it works as intended. I have a problem with my smart contract here because I'm missing a semicolon. Okay, it's fixed. So back to the Run tab and let's deploy our smart contract. And let's expand the contract instance and let's create a couple of users. So Joe, Dan. Okay, so we have two users. So if we try to read the first one, then we're able to read it. If we try to read the second one, then we're also able to read it. And how about if we try to read a user that does not exist? And here in the Remix console, then we can see that there was a problem. VM error revert. The transaction has been reverted to the initial state. Reason provided by the contract. User does not exist. Great, it works as expected. We still have a last problem to fix with our smart contract. So to demonstrate what's the problem, I'm going to delete the first user. So here I click on destroy. Okay, so I've destroyed the first user, and now if I try to read the first user, what do we see? We don't see any error in the Remix console, and here we see an empty string. We were expecting the revert statement here to be triggered, but it wasn't the case. So what happened here? So in Solidity, when you try to access a struct that does not exist, you can still read its field, and its field will be initialized to the default value of each type. So here in the find function, when we try to retrieve the user with the ID of 0, and here when we iterate through the user array, so first we try to find the first user and it doesn't exist, and then we try to read its ID, and we're still able to read its ID because it's going to be initialized to 0. And so when we compare this with the ID that we pass as argument, that it matches, and this function return the first user that does not exist, and then this non-existing user here as an empty string. And so that's what we see here. So obviously that's not correct. So we want to avoid the situation here where we basically this comparison is truthy. And to avoid this, then let's scroll up and we just need to make a tiny change. So here we have our variable next ID, which will be used every time we want to create a new user. And so we want to avoid having a user with an ID of 0. So here we can initialize our next ID to 1. And so we will never have any user with an ID of 0. So now let's delete the old smart contract and let's redeploy the smart contract. We're going to make sure that everything works fine. So we recreate some users, Joe and Dan. Now let's try to read our first user. So this time the ID is 1, it's not 0. So yes, we can read Joe and we can also read Dan. Okay, and so now let's delete Dan. So user ID of 1. And now what happened if we try to read Dan? And this time we have an error here in the Remix console, which is the reason user does not exist. So it works, we have fixed our problem. So you can be proud of what you've learned so far, and you start to reach a level where you know quite a few syntax and types of Solidity. You can do all the basic operation around data, create, read, update, and delete. That's very good.
Congratulations for reaching this stage. That's the end of the first part of Smart Contract 30. If you want to continue with the 25 remaining videos of Smart Contract 30 and really push your knowledge to the next level, then go to the website of EatTheBlocks Pro and take the monthly subscription, so all access subscription here. And for $10 a month, then you'll get access to all the videos of EatTheBlocks Pro. If you have any question, please ask me in the comments. Thanks for watching and see you in my other videos.